Hi, today I would like to show you some of the new features I've added to my online waveform viewer. It is still a tool for educational purposes, mainly for getting some insights on how a waveform behaves under different circumstances. So without further ado, let's get into it. So as you can see, we still have the current uh, and voltages and the digital inputs on three separate channels. So this hasn't changed. I've instead of having a typical menu, I've basically have these three panels that will show you how to use them and why they are there. Um, so what you have here is a way to simulate different fault types. So now I've got three-phase faults. If you click on these, you'll be able to have a single phase to ground. Here I've got the B to ground fault simulated, C to ground, A to ground. Same thing for the phase to ground. Okay, difference C to A to B, and phase to phase without ground. Okay, uh, you are still. Let's. I think this is better to show it on the B to ground here. Uh, Here you've got the ZL that is shown here with 1 ohm for the resistive part and 10 ohms for the reactive part. So the load resistance is about 100 ohm. So for a short circuit here on the B to ground, if I increase the impedance, the reactive part, you can see how it influences uh, the decay of the fault here. You've got the same thing for the zero sequence on the line side. You can increase or decrease and see how this affects the waveform decay, uh, which is basically the X over R ratio that we typically use on overhead line protection. Here, the same thing for the source impedance. Here I've got an equal impedance, so the source is equal to the line impedance. So you can see how it affects as well the waveform and the resistive part as well. So you can see that the resistance has as well an impact on how the waveform is behaving, right? So this is pretty interesting to visually see. Now, if you want to see how this is reflected on the impedance plane, so you click here on Open Z mode. You can see that it's simulating this. I'll think I'll just refresh. Okay, let's restart. Refresh this. So if we click on the Open Z mode here, we are able to see the load impedance here and how they depart from their position to the fault condition on circulating fashion here. You can see that the ZB here is obviously uh, setting its target at the fault value, and you've got ZBC and ZAB on the healthy phase, basically, that are swirling around. Here you can hover your mouse uh, on each point and see what are the values. Here the resistive part, the reactive part, and the angle at each of these samples values. These are instantaneous values, obviously. So this is for the impedance. Obviously, you can change all these for BC to ground fault, right? You can see that it's color coded for this ZBC now. It's obviously setting to the fault value, and ZCA and ZAB on and ZCA and ZAB. So this is a nice way to actually look at how this is seen by distance protection, for example. Right. So let's close this. Now, if we look at this same graph, but with taking these instantaneous values and calculating here, for example, zero sequence, positive and negative sequence impedances, as well as the apparent powers on the ABC phase, as well as the zero, positive and negative sequence. You've got different values here. You'd be able to see how all of these are impacted by the fault. Okay, so you are able as well to get the instantaneous values as impedance on the polar or Cartesian values, right? So this is a nice way for flexible interpretation of each of these impedance values. So these are the main things that I wanted to show you. Here you can as well change the point on wave. So the distance to fault, the nominal voltage, which is 110 volts here, which is a secondary side voltage, obviously. So here you can as well, since we are in the BC phase, you can take the A to ground here, for example. You can take it out of the picture. Same thing with the voltage, and see how only a dedicated view on the faulted values. So, for example, if we look at the C to ground here, you can take V out and only see the voltage and current, for example. Right, so let me know what you think. If you've got any feedback and comments, I'd appreciate it. Thanks very much, and talk to you later.